What's up everyone, this is going to be a very quick video on how to work with Geometry Stencil HDA node. At the most basic level, you can align your input geometry along the z-axis within your given bounds. So the HDA node requires for you to have two inputs. First of all, the bounds that the geometry is going to be aligned within, and your geometry pieces. In this case, in this example, I am creating this kind of a bigger tile from smaller tiles. In this case, I have basically just these two roof pieces that I'm creating a bigger one, and which I actually then feeding it further down the line within another Stencil node to create more involved setup, something like this roof setup, which uses also different nodes. But in this case, in this video, I just want to talk about the actual stenciling of the geometry. And you can also go ahead and start. We do not also have to give it only a square geometry. You can basically give any shape you want. In this case, you can also Boolean out, and at the end of the this output of this HDA will be, you can see it's going to also cut the piece also inside here, something like this. So let's go ahead and take a look at how to set it up. So first of all, let's turn off this one. So we need our plane that we want to align our geometry in, and then we need geometry pieces. And the only thing that we really need from here is we need some sort of a piece attribute, string primitive piece attribute. In this case, I have my attribute name, tile name, and I have given it a unique ID for each one of these, for each piece. So I have tile 99 and tile 98. So inside here, inside Stencil Geometry HDA, I go to the prepare tiles, and I'm saying that my piece attribute is tile name. It's going to basically automatically pick up any string primitive attributes underneath, and then we can say, okay, I want to say which tiles to use for the scattering of these for the alignment. In this case, I have taken both of these, but if you want only one of them, you can also select only one tile or whatever you want. And if you there's no entry, that means all the tiles that you are inputting in the second input is valid for the alignment. So, in the way that we select these tiles are actually done from the randomized tiles options. So we can cycle, we can patches, we can create like these patches, we can noise, and then there's a bunch of element size and some like this, all just randomize them. And you can see that they are going to be aligned and going to be scaled within the bounds of the bounds. So we have ability, go to the prepared tiles, we can also overlap these tiles. So you can see that when the overlap is at 0, it's going to take automatically bounding boxes of these tiles and going to align them. You can see in this case, alignment is basically within the bounding box. There are some rotation, which is done inside here. We can pitch our tiles. If you go ahead and say, okay, pitch them. And to make it quicker, actually, I'm going to disable the Boolean. I'm going to maybe say, okay, pitch them. We can also yaw them. You can see whenever if you're creating something like a roof and you want to overhang your tiles because they are connected like overlap each other, you can these. And you can also change the pivot that you want to create your yaw from the Z max or the pitch pivot. And this is basically a local pivot for each one of these pieces. For something like a pitch, you always want to make sure that most of the time if you're making something like a roof, you want to say, okay, I actually want to pitch from the Y max option. Like this. Let's disable the yaw, we do not need that one. And then we can also create a little bit of a jitter, especially if you are creating something like a roof tiles. There's always going to be a little bit of a play between the tiles. Depends on what you're making. Obviously, this is not only intended for use for the roofs. You can make many different kind of geometry from this tool. And let's talk about the alignment and Boolean option. So whenever you are not Boolean it out, the tool is going to be the fastest then. But if you're going to go ahead and start to think about stenciling it, you have to go to the Stencil tab, and you need to set up a couple of options for your how the Boolean is set up and how we fit our tiles. So for something like this geometry, this would be a good idea for us to not to cut something like at the middle of the tile. So what you can do is say, okay, actually scale to fit Y option. So you can see if I disable the scale to fit Y, you can see that even though my tile doesn't fit, so it's basically since I'm basically catching a little bit of this tile, so that means it also has to be copied. So, and if I go ahead and say, okay, go ahead and start Boolean out this stencil, you can see it's going to catch the last tile. And if I'm making some like a roof, I don't really care about this little cutout. So this is why the option scale to fit Y exists. So we're going to take this tile and we're going to scale it to fit the bounding box. And then say, okay, Boolean and out. And if the Boolean, if your input geometry is basically a square, you do not even need the Boolean won't really do anything because the bounding box is just a little bit smaller than the input shape it's going to bound by. So the Boolean won't mess up any of your UVs. So it's kind of a good thing to have. And the same thing is about the Z. So the Z doesn't really matter in this case too much because all of our tiles are the same size. But if we had something like a 2 tile sizes, and if we say we do not want to scale, let's go ahead and say the randomization, not this, maybe some like patches. You can say since we can't really control what tiles are going to be copied, if we do not scale by any of the axes, you can see there's going to be an overlap. So whenever there's overlap, if you Boolean it out, it's going to bound by this. And obviously you want to use Boolean if you do not have a regular shape, like in this case. You can see if I use this one, if I disable Boolean, it's going to just take the bounding size of the input shape. So you always want to use a stencil, Boolean stencil, when you have not a square, a rectangle bounding box like this. And then there's also options for the scaling before the Boolean. And for something like a tiles, since I don't really care about the Boolean it out, I won't even bother with this one. And the second very quick example of how I have used this node is actually creating this from this geometry, actually marking it as another tile name and feeding it inside another stencil geometry. In this case, I'm having this kind of a geometry, and I'm using my trusty transform to origin geometry node, which aligns each one of these faces of the geometry to along the z-axis, which is exactly what the stencil geometry requires to do, to stencil out input geometry with all these irregular shapes. And what I'm doing I'm just feeding it. Again, I'm saying tile name. In this case, my tile is 97, and moving it back to it, and I'm getting this kind of result. And I'm also using my trim node, which I also going to, which is another tool that I'm working on, and should be in the description of this video to show you how it works. So basically, just trimmings around this geometry. And that's it for this video. I hope you like it. The link for this tool is in the description, and see you next time.